This is Mr. Anderson for Kellogg Community College, and we're going to be looking at our fourth of 5 videos to establish identities in Chapter 3, Section 4. Okay, so this one really kind of made me think about how to look at some of these problems, because man, no other problem has actually taken this direction. But since I noticed that my denominator is already in cosine and my numerator is in sine, I can write an equivalent expression of sine squared theta as 1 minus cosine squared theta. Now, where this goes is I can take this as, and again, this is a pretty elegant way to do this, I can take this as 1 minus cosine theta squared. Now, what I have here now is a difference of squares, which again isn't really that apparent, but if you call this 1 minus x squared, then you could factor that into 1 plus x squared and 1 minus x squared. So what this means is that I can write the problem as 1 minus 1 plus cosine squared and then 1 minus cosine squared, or sorry, cosine theta and 1 minus cosine theta, all over 1 plus cosine theta. Now what's cool about this is we can simplify those two because they divide and make 1. Now I have 1 minus this 1 minus cosine theta, and if I distribute the negative inside there, I got 1 minus 1, which is 0, plus cosine theta. So my answer is cosine theta, and I've now established that identity. Pretty clever trick that is. Looking down here, this is a little bit more another obscure kind of solution to try to get this left side to look like the right side. And I think what's kind of fun is to do these problems out of the book. If you're completely stumped, you should try to copy them down and see the tactic that which they took. And the more you actually spend time with these, the more you can maybe see where things have come true. And what I'm going to do, and this is kind of interesting, because I'm going to multiply the top and bottom by the same thing. And I guess my only possible hint is that my answer over here is tangent. And what I have here is sine and cosine. So I think if I multiply the numerator by 1 over cosine theta, what's going to happen is the cosines are going to simplify, because I'm going to have sine theta cosine theta divided by cosine theta. And what that's going to do is going to give me a numerator of tangent of theta. So I've now taken half the problem and I've gotten it completely finished. Now, anything I do to the top I have to do to the bottom, because this is technically multiplying by a giant 1 here, and I have to have the same numerator and denominator. So this gets basically distributed all across the bottom here, and this is going to be, hold on a second here. This should, oh, you know what? This should have been cosine squared. This is me making a little mistake here. This should have been cosine squared, because if I have all the cosines cancel out or simplify, then I would only have sine left on top. So if I use a 1 over cosine squared, only one of the cosines goes away, and now I'm left with sine over cosine, which is tangent. Which means down here I now have cosine squared theta over cosine squared theta minus sine squared theta over cosine squared theta. And what's nice is that simplifies to 1, and then this simplifies to tangent squared theta, sine over cosine. So again, my little mistake here is I should have multiplied top and bottom by 1 over cosine squared, so I would have left 1 cosine in the denominator, so sine over cosine is tangent, and then sine squared over cosine squared is tangent squared theta. All right, let's move on to the next 2 problems out of 5. And let's go take a look here. In problem number 18, I've got secant minus cosine and secant plus cosine. Sometimes when you're stuck, you may want to try to get everything in terms of sine and cosine, and the secant is the reciprocal function of cosine, so I just made that happen in my numerator, and my denominator will also look similar to it with a plus cosine theta. Now, what I'm going to do is I'm going to get common denominators here, so I'm going to multiply this problem by cosine theta over cosine theta. I'm going to multiply this one also by cosine theta over cosine theta. And I'm doing that because what that gives me is it gives me this 1 minus cosine squared theta, that's really helpful, over cosine squared theta. And in my denominator, I'm going to have 1 plus cosine squared theta over cosine squared theta. And what's nice about that is this numerator here of the top fraction turns into sine squared theta over cosine squared theta. Now don't turn this into tangent because we kind of have that little piece right there. And then down below we got 1 plus cosine squared theta over cosine squared theta. And again, we have this piece right there in the third level. Dividing fractions, you skip, flip, and multiply. So instead of dividing this one by this one, we're going to multiply by the cosine squared theta over 1 plus cosine squared theta, because this bottom fraction flips up to the top. These simplify to make 1, and then we have our established identity of sine squared theta over 1 plus cosine squared theta. Now, if this process in problem 18 seemed a little confusing, go back to the previous videos and you'll see more problems like these. So I do find myself pushing myself through them kind of quickly because we've covered them a couple times before. You can see I erased this here because I made a mistake going through this problem. I'm going to turn this into 1 over cosine of theta over 1 plus 1 over cosine of theta. I'm going to get a common denominator here because maybe they'll get me closer over here to what I need. So I'm going to multiply the top and bottom by cosine of theta, cosine of theta. What this gives me is 1 over cosine of theta over cosine of theta plus 1 over cosine of theta. Now I'm going to skip, flip, multiply. I'm going to bring this to the top here. I'm going to have my 1 over cosine theta times, I'm going to have my cosine of theta over cosine of theta plus 1. Now what will happen is I can simplify this. So this gives me a 1 plus over cosine of theta plus 1, which looks absolutely nothing like this, does it? So with nothing left to do, maybe if I multiply by the other part of the difference of squares, the cosine theta minus 1, this is going to give me something I can use. And in fact, it gets me pretty close up here because now I have cosine of theta minus 1 over cosine of squared theta minus 1. That's foiling these two binomials, and you would have cosine squared and then minus cosine plus cosine, and then we'd have minus 1. But you can still see that things are just not quite the same up here. So what I'm going to do is I'm going to factor out a negative 1, or actually multiply both top and bottom by negative 1. And what that is going to do is it's going to flip the top around, because this is going to be a negative cosine theta and a positive 1, so I can rewrite it the way I want to see it. And down here, I'm going to distribute the negative 1 to everything. So now I have a positive 1 on the denominator minus cosine squared theta, which is, lo and behold, 1 minus cosine squared theta, as used many times in our worksheet, this section, is sine squared theta. All right, for my final problem, let's go take a look here. For my final problem, let's go see got my tangent plus cotangent. How is that ever going to make our secant theta cosecant theta? Well, if all else fails, just tear everything down into sine and cosine. So here's sine theta over cosine theta plus cosine theta over sine theta. And since I got no other choice, but I think let's just get a common denominator. We'll multiply this one by sine theta over sine theta, and multiply this one by cosine theta over cosine theta. Again, because what we're doing is we're trying to get a common denominator. So this is sine squared theta over sine cosine, and this is going to be cosine squared theta over sine theta cosine theta. So we have a common denominator, we add our numerators together, and check this out. What's nice about that is now sine squared theta plus cosine squared theta is 1 over sine theta cosine theta. And then that makes, if I can break this up, 1 over sine of theta times 1 over cosine of theta. Now we can turn these into the reciprocal function, which is the cosecant theta, and this is going to be the secant theta. And using my commutative properties, commutative property is going to just switch the order, secant theta, cosecant theta. And thank you for watching the fourth of 5 videos.